When people ask me where I got this necklace, I answer honestly. I made it. I cut the glass, free-handed in the tree, slumped the glasses together, and attached the ornament to the necklace. A surprisingly more difficult question, however, came to me in the form of a slightly less than sober girl at a party one night. "Oh, why is that so shiny?" she asked. I had no answer for her because, frankly, I didn't know. So, as many good college students would do, I stopped what I was doing immediately, bid the maiden farewell, and ran home to find out. This presentation is a summary of the answer I should have known that night about a decidedly metallic and color-changing glass called dichroic glass. Depending on who you ask, glass actually refers to a state of matter rather than a particular chemical. It can be defined as an amorphous solid that is cooled to rigidity without crystallizing. Glass is widely considered a supercooled and very viscous liquid. So what is glass actually made of? The main constituent of flat glass is silica sand. Silica has a giant crystalline structure and is made of silicon atoms covalently bonded to oxygen atoms. These oxygen atoms are covalently bonded to other silicon atoms, and so on. This setup makes glass a very hard structure, which requires very high temperatures to melt because the covalent bonds need to be broken. Its melting temperature is somewhere in the range of 1700 degrees Celsius, and its state at this temperature is similar to that of syrup on a very cold day. Glass's high melting point can be reduced by adding a chemical called a flux. In normal glass, the flux is sodium carbonate, which becomes sodium oxide, or simply soda, in the glass. These atoms are known as network formers. Calcium carbonate, or lime, is added to the glass as a stabilizer. This prevents the glass from dissolving in water and is called a network modifier. When the soda-lime silica mix is melted down, it becomes amorphous. This means that it has a regular, random arrangement of its atoms. This mixture is cooled quickly so that its amorphous structure does not have time to form regular structure or crystals. This structure contributes to many of the important properties of glass. Most importantly, it has no obvious melting point. Instead, its viscosity just decreases so that it begins to flow and can be molded or blown. Other than to help define glass's actual structure, minerals are added to glass for purely aesthetic appeal. In addition to natural impurities, glass is colored by purposely adding purified metal salts. Examples of popular colored glasses include ruby glass, seen here on the right, which was invented in 1679 using gold chloride, and uranium glass, on the left, invented in the 1830s. Yes, it actually glows in the dark. Sometimes it is necessary to remove unwanted color caused by impurities to make clear glass or to prepare clear glass for coloring. Decolorizers are used to precipitate out iron and sulfur compounds. Manganese dioxide and cerium oxide are common decolorizers. Iridescent glass, sometimes simply called iris glass, is made by adding metallic compounds to the glass or by spraying the surface with lead chloride and reheating it. Dichroic glass is an iridescent effect in which the glass appears to be different colors, depending on the angle from which it is viewed. This effect is caused by applying very thin layers of colloidal metals, such as gold or silver, to the glass. Colloidal-sized particle is defined in diameter from 1 to 1000 nanometers. The very thin layers are usually coated with clear glass to protect them from wear and tear or oxidation, but are not flat. The deposited oxides have no intrinsic color themselves. Instead, it is the physical properties of the metallic oxides in the dichroic glass that cause different wavelengths of light to either reflect or transmit more than others. These properties cause certain light waves to be reflected, while others travel through the glass, along slightly different paths, thus causing the color shift we observe. Most dichroic glass uses both transmission and reflection of light to achieve the desired effect, so that as you rotate a piece of dichroic glass even slightly, you'll see a shifting rainbow of colors. Adding to its complex optical properties, dichroic glass, when fused as part of a glass object or piece of jewelry, will change characteristics yet again with the new colors, shifting towards the blue end of the spectrum. Now you too will have a 5-minute explanation as to why dichroic glass is colored the way it is and is so shiny the next time someone asks you at a party. You're welcome. You finally reached the end.